Good afternoon. So it is very tough for me to handle the third session, right? Lecture 3. The topic of the lecture 3 global green energy initiatives and green ammonia projects. So what is the learning objective? So why we are going to study this topic? What is the importance related to this? The theme. To understand the global energy initiatives and explore various green energy sources. As Professor who already mentioned that what are the green initiatives that taken place across the US. So we need to explore the same way what India is exploring in green energy initiative. And then to analyze the role of ammonia, as you know that ammonia carries hydrogen in terms of weight basis. The amount of hydrogen energy density in hydrogen, the amount of energy density available in ammonia in terms of hydrogen. You see the compare the values. Ammonia has more energy density in terms of hydrogen present in hydrogen. Then the third one, to identify challenges and opportunities, already who mentioned in the second lecture. What are the challenges? Why the SMR methodology, steam methane reforming methodology concept is not ruled out completely by bringing the green energy initiative? What are the drawbacks? What are the obstacles there? Switch over from the Haber-Bosch SMR concept from producing ammonia from natural gas or methane, right? And it is a well proven for 100 years. The Haber-Bosch technology is the well proven technology. Because of the Haber-Bosch technology, I can say both the scientists, both belongs to I can say German scientists. They got the Nobel Prize. 100 years back, the technology was evolved. Now this is one of the best technology. Is not replaced so far by even bringing the green energy initiatives. To discuss the future trends and technological advancement in ammonia projects, we are going to talk about microwave, we are going to talk about biological, we are going to talk about the plasma, cold and hot plasma technology, and also we are going to talk about the pyrolysis and gasification from biomass, how the ammonia can be generated by producing hydrogen, how the hydrogen can be separated from all the sources. So learning overview of the end of this presentation, you are supposed to know what is green energy, what are the global energy initiatives, what are the green energy sources you come across, and it is also advancement available across the world, challenges in green energy adaptation. So what are the challenges? How the SMR technology can be still, I can say, achieving the hydrogen production, or I can say ammonia generation is not going to be replaceable. What are the challenges with respect to green energy adoption? Introduction to green ammonia, global green ammonia projects across the world, challenges facing in green ammonia. So what is green energy? As you know that the green itself is natural. The energy is produced from natural source like wind, solar, hydro, renewable, geo, ocean, I can say wave or tidal, also thermal energy conversion. These are the methodologies, right? We are using for producing the electricity. Either I can say electricity directly or producing the mechanical work. Then we are using an electrical conversion device to produce the electricity. So what is the ultimate aim in moving towards the green energies? We are going to reduce the carbon emission. We are going to completely eliminate, because every 1 ton of ammonia generation we are producing about almost 100 tons of CO2. 100 tons of 100 times the CO2 comes up if we are using the source from the carbon like methane or methanol or ethanol, whatever may be. We want to completely eliminate the carbon and hydrogen generation or ammonia. If it is apart from the carbon production, I can say COX, we can say carbon monoxide and CO2, we can able to save the environment. And the ultimate aim in going for green energy. So we all know that there are all the different green energy, wind energy, solar, hydro, geothermal, and I can say biomass. We are somewhat doing in Tamil Nadu, across Pollachi or Thoothukudi. We are able to produce some, I can say, gigawatt power windmill is coming out in onshore, offshore. We are We are working on it, how we can able to take the energy. We are poor in offshore, I can say. Onshore, we are working there. Solar, I think we are having, I can say, few gigawatts of power coming out from solar photovoltaic and direct electricity from solar photovoltaic to the electricity. Now, the lot of incentives are given by Government of India through MNRE, Tamil Nadu, I can say Tamil Nadu Energy Development Agency, and Indian Renewable Development Agency. We are getting lot of incentives to promote this, not only for, I can say, to generate the power for the industry as well as for the people, and also lot of incentive given for the people also to install the solar PV in their own house. Hydro, as you all know that we have the way tour, we are producing the power through hydro, through the potential energy between the head difference, the power is coming out. Then geothermal, I think in India we are very poor in geothermal. The potential of geothermal energy, I can say we need to really work on it. It is a high capital cost is involved for creating this geothermal. Biomass, there are a number of projects are happening across the world and India. Our technology is very well acceptable in terms of producing gas or oil from the solid material. So IAC, Indian Institute of Science, under Professor Mukunda is doing a lot of research in this area to produce the hydrogen from biomass. In Tiruchi also, I can say in the mechanical department, I am doing the research, biomass pyrolysis through electrical, microwave and plasma technology. Whereas in the chemical department, Dr. Sriba, Dr. Sarasandra Babu, Dr. Samsudin, there are many people in chemical department also doing a lot of work in producing producer gas. We call it as a synthetic gas, contains two constituent carbon monoxide and hydrogen, and we are currently focusing on producing the hydrogen before the process happening in the gasification system. The pre-treatment of wood before acid leaching and all the process happening. We have the patents also in this area to produce hydrogen at the pre-treatment itself to enhance the hydrogen from the which is coming out along with the carbon monoxide. And ocean and tidal energy, I think ocean tidal we are not, I can say, in terms of promising technology we are having. Whereas the European countries like Denmark, Norway, Finland, they are well ahead of, I can say, producing the energy from the terms of ocean and tidal. Global installed renewable energy generation capacity, we can see that in up to 2022, there are 3,392 gigawatt power comes up the installed renewable capacity. In this, you can see the maximum percentage comes from hydro and solar PV and wind. So these are the major power coming out from three sources. The first one is the hydro, the second one is solar PV and wind offshore. Even today morning, our HOD mentioned that we have installed 10 kilowatt power in our mechanical department faculty block. There we are average, we are delivering 5 kilowatt power to our grid, which can be utilized for our LIDT. So you can also be taken into that plant, you can be able to visit that. Then 2030, we are the focus of can say renewable energy generation capacity increased. I can say from 3,380 to approximately 3.8 to 3.9. The expected renewable energy generation about 11,000 gigawatt. That is 10 power 9 watts. Okay. So among these, you can see here. Still, you can see here that there is a huge development in terms of solar PV. You can see here within 8 years, we have to multiply the capacity from 1,055 to 5,457. 5 times. So, our government of India has already started an initiative, and we are planning for, can say, very high capacity of solar PV, which can be not only for electrifying the villages or electrifying the industries, and also we are going to use this power for electrifying the automotive, electric vehicle also. And the solar PV, the concept, we are also not only among the three applications I mentioned, we are also using this energy for producing the hydrogen. Because we need a huge power which can be used for dissociating the water into hydrogen oxygen. We need power for dissociation for electrolysis process. So we are going to create maybe each capacity of electrolyzer. We can create our own solar PV system And instead of depending on the grid, we can able to, I can say, take the power from solar wind for the green energy, green hydrogen generation. So among the solar PV, you can see here, among the solar PV, there are, I can say, there are other way of extracting the solar also, solar thermal, but it is not emerged like what European countries are doing, because the temperature of the fluid what is coming out from the solar thermal is about 40 to 55 degrees centigrade. The working fluid what we need to use it for solar thermal power generation is probably, I can say, all the refrigerant what you are using in the refrigeration air system, that can be used as working fluid, because the boiling point of the fluid which can able to the heat available for converting into vapor for producing the steam which can be used for running the turbine. We need a low boiling point fluid. So a lot of research is going on in that area also. And also you can see here the bioenergy is, you can see there the 3 times the bioenergy improvement going to happen within the 8 years of time. Bioenergy not only deals with the biomass or biomass gasification of bioenergy, and also deals with biodiesel also. Okay. So what way we can able to convert the available sources apart from solar, wind and hydro, biomass also plays a major role. So there are different, I can say, initiatives are across the world they have taken. There are around 12 to 30 initiatives are taken. The first one is the Paris Agreement, which was happened in 2015. There are about 196 countries are participated. They are part of the Paris Agreement of 2015, which was held in Paris. It happened in 2015, but the document was created in November 2016. The ultimate aim in Paris Agreement is the global temperature should not exceed, I can say, 1.5 degree above or less than 2 degrees centigrade. So they have to go for different initiatives to ensure that the global temperature should not exceed more than 1.5 degrees centigrade. Then the next one is, you may come across any recent proposal given by Department of Science and Technology or this, or any industries are cooperating with this one, any call across world, across the, I can say, India also. The most important initiatives are United Nations Sustainable Development Goal, SDG 7. There are around 17 goals are there. With respect to this theme, we are focusing on goal 7, where it is focusing on carbon neutral, how to reduce the carbon which is coming out from the many sources. So they are ensure access to affordable, reliable, sustainable and modern energy for all by 2030. So by bringing the green concept to eliminating the carbon to the maximum level, so we can able to bring down the temperature less than 2 degrees centigrade. Focus on expanding renewable energy in global energy markets, improving energy efficiency and increasing the energy access. You can see here the ultimate aim is SDG 7 goal is, there are, I can say, still in 2022 as per their initiative, there are still 675 million people are still living in dark. The problem is how to, in some places, even you can see in Tamil Nadu, there is no electricity at all in the hills region, but they have the local sources of, I can say, local energy available, but the energy conversion systems are missing. So we this SDC code talks about, under this call also recently we received one project from DST, how to make use of the locally available biomass. We are going to implement that concept in Thorayur, Nambambatti, where they are using that propane corn, that is called Tamil we are saying Maravali. So the waste comes out from the after extracting the material from the propane corn, Maravali, what 2/3 of the weight goes to waste. So what they are doing in the hill region is they are simply firing, open firing they are doing. Lot of carbon particles comes out and it's going to create a lot of nuisance to the environment. So they are creating the energy, but it's not utilizing it. So we wrote a proposal, we submitted a proposal and a clear energy initiative of DST C3 call. We received 1.2 crores of the project, where we are bringing the concept of biomass gasification concept
and bringing a solar photovoltaic also for creating the electricity to run the auxiliary which is there in the power plant.
We are going to produce the biomass waste into a carbon monoxide hydrogen producer gas. We are going to separate out carbon monoxide hydrogen, or we are going to burn it to produce the steam which can be used for gasifying producing hydrogen, and also we are going to use that high concentration hydrogen or producer gas for running the engine, which can able to produce the local power, which can able to I can say run the cold storage of 60 or capacity. Locally we can able to create the power, and also locally we can able to store the food which what will be created inside the particular minutes. This is under SDG call. So people always start working on SDG call. So our ultimate aim, if you are submitting any proposal or doing any research, ultimately you will ensure that you are going to produce the energy that can be used for running your system, not to consume energy from the grid. So next one is European Green Deal, because the initiative was happened in European Union. Make the European Union climate neutral by 2050. They have set the target 2050. They want to say that the I can say carbon balance. How much is you are emitting? How much is going to be consumed? That's called circular economy. So you cannot produce, you cannot consume more. You can consume more, but you cannot produce more. So you have to balance it. Climate change and environmental degradation are existential threat to the Europe and the world. To overcome the challenges, European Green Deal will transform the European Union into a modern, resource efficient and competitive economy. No net emissions of greenhouse by 2050. So after 2050, they are saying that there may not be any more greenhouse gas emissions, which is going to absorb the heat which is coming out from the various sources. So they are completely the aim is to completely eliminate the carbon footprint, economic growth and decoupled from resources. This one is instead of producing the power from the particular site, they are going to say that instead of producing 50 megawatt or 100 megawatt on place, you create a local gen. Tiruchi, I can say here to Tiruchirappalli. I can say you can have in Tlapudi, this place called Tlapudi. You have maybe I can say 1 megawatt, you can create a power here. Maybe in city you can create 2 megawatt. Maybe in I can say Karur you can create some power. So you can create the power needed for the particular place, then and there itself, so that the emissions which will be coming out from the different I can say different plant will be neutrally balanced. Then the renewable energy 100 initiative. This is the initiative taken by USA. The head office is there in New York City. Which has, I can say, 400 plus members, 500 plus tons per year committed to 100% renewables. So, what is their aim is, they are, these initiatives taken by various industries. So, different industries across the world, Tata Motors, Siemens are participate, they are part of this membership, and their aim is to go for their industry in the form of green energy. Mission Innovation, MI 2015, it was launched. The goal is to, I can say, putting a net zero carbon emissions. So, Mission Innovation 2.0 launched 2nd June 2021, catalyzing a decade of action and investment, research, development, and demonstration to make clean energy affordable, attractive, and accessible for all. So, this is innovation is based on the Paris Agreement. Ultimately, all the agreements, innovations, ideas, or incentives are happening across the globe based on the Paris 2015 initiative. So, International Solar Alliance, I can say, this is the particularly for solar. They are going to mobilize efforts to scale solar energy deployment worldwide. So, our India also part of this. Our UN Climate Change Conference in Paris was happened. So, President of France and Prime Minister of India signed a memorandum of understanding, and our India and France is the leading, I can say, country in bringing the solar initiative across the world. China also having the green energy policy. So they are also having the same like European Union, 2050 they fix the target to reduce the carbon completely, NOx emissions completely, or greenhouse gas emissions completely. US clean energy plan. So the ultimate aim achieve carbon-free power sector in US by 2035 and net zero emission by 2050. So ultimately, by bringing the clean energy initiative in US, they are targeting, I can say, 4 parameters: lowering the cost of the system, creating more jobs, cutting pollutions, historic action, which can be able to eliminate the conventional way of using the power generation. India's renewable energy initiative under this IRDA, MNRE and Tamil Nadu Energy Development Agencies are playing a major role. We can see here in 2021 and 22 to 2029 30, you can see here the renewables going to be play a major role in Indian, I can say, power sector. So India's renewable energy capacity is projected to grow rapidly, 35 to 40 gigawatts added annually through the through 2029 and 30, achieve 500 gigawatt of renewable energy capacity by 2030. So that is the goal of the renewable energy initiative. India has been one of the champions globally in adopting renewable energy as part of this energy transition. So similar to this, African countries also going with the renewable energy initiative, AREI. They are also bringing lot of new renewable energy concepts. Hydro, solar, then I can say wind and biomass. So they are going to also have the, at least by 2030, they are going to produce 300 gigawatts from the renewable energy sources. So here now you may come across international renewable energy agency. Most of the funded world level projects are coming through IRDA. Promote renewable energy adoption globally and provide support to governments. Mostly IRDA is the agency which supports, I can say, European. Mostly the European countries are part of this IRDA. They are going to have the generation, you can see here, up to, I can say, 2040 is around 365 gigawatt they have planned. So it's going to increase. Global jobs also going to be increased by bringing so much of clean energy initiative. And you can see power generation expected. And I can say 2023 USD per kilowatt hour. You can see here up to 2023. You can see here the power generation with respect to renewable energy going to be play a major role. Green hydrogen initiative. So this is our theme of our workshop. So develop a green hydrogen as a zero carbon energy carrier fuel to make India the global hub for the production, usage of export and green hydrogen and its derivatives. This contributes India's aim to become the Atmanirbhar. This is an initiative given by the government of India under the Prime Minister's leadership, Modi leadership, through clean energy and serve as an inspiration for the global clean energy transition. The mission will lead to significant decarbonization of the economy, reduce dependence on fossil fuel imports, and enable India to assume technology and market leadership in green hydrogen. You can see here, supports domestic and manufacturing electrolyzer is under this initiative, offers incentives on production of green hydrogen. 5 million metric ton of green hydrogen we are expecting by 2030 under the National Green Energy Initiative. And you may come across MNRE already launched a 500 crores project for green hydrogen. Under this, lot of industries and leading institutions are participated. From NIT, there are a few number of projects also submitted under this call. There are 50 million metric ton of carbon abatement cumulatively going to happen. 60 to 100 gigawatt electrolyzer installation going to happen in the near future to produce the green hydrogen. 125 gigawatt renewable energy from green hydrogen production. Over 8 lakh crore investment going to be happen across the India from the leading. Already you know that Adani is going to invest at many, I can say, renewable energy projects. Similar to that, and Ammonia also, Tata Group also invested huge fund for this, bringing the green hydrogen outcome. Because the ultimate aim in bringing green ammonia or green hydrogen is we can able to run the engine, we can able to produce the emissions apart from CO2. And also hydrogen you can use it for running a fuel cell. So similar to solar PV, you can directly produce from the fuel electricity. No need of any mechanical energy conversion system. So global wind energy, this is initiative pertains to the wind energy generation for offshore and onshore. The government has set an ambitious target of 175 gigawatt of installed renewable energy capacity by 2022. It is going to increase in the coming years. So efforts towards green energy transition in India. In 2019, India announced that it would take up the installed capacity of renewable energy to 500 gigawatt by 2030. Production linked incentive schemes also introduced by the under Green Initiative. PM Pradhan Mantri Kishan Urja. This scheme aims to provide financial and water security to farmers through harnessing solar energy capacities. About 25,750 megawatt by 2022. Ministry of New and MNRE on its website also posts Akshay Urja portal and Indian Renewable Energy Exchange portal to give awareness about the new initiatives of green energy initiatives. India is witnessing significant increase in energy consumption, evident by 2 times the growth of its energy consumption over the last 2 decades. Further, energy consumption in India is expected to grow by another 25% within 6 years of time. The report further states that major sectors in India are still dependent on imported fossil fuels. To attain a net zero carbon emission by 2070, the government has taken necessary steps and recognizes the negative impact of fossil fuels on the environment. So changes, as already Professor Wu mentioned, the foreman organization, the cost of infrastructure, the energy storage issues, how to store the hydrogen, as the molecular weight of hydrogen is very, very low. It is the lowest among the I can say all the gas you come across in your life. Then intermittency, because it depends on the season. You cannot get the continuous power like the coal power or nuclear power generation. Then grid integration, how to integrate the grid with respect to the new renewable energy concepts. So the 4 challenges, a lot of research work is going on. How to store the electrical energy, how to store the take the energy from the battery, how to store the hydrogen, how to I can say how to store other gases needed for producing the power is a challenge. So introduction to green ammonia, we come across there are three types of ammonia you come across. There are black ammonia also there. So if the ammonia is produced or hydrogen is produced from the coal is called black ammonia. If the ammonia is produced from, I can say natural gas, methane, we can say it is the brown ammonia. But what is the fundamental difference among these? The raw material here is natural gas, here also natural gas. Here it is the water. Here it is the water. So for both the methods, the raw material remains same. Why is called brown ammonia? Why is called blue ammonia? Here, the concept involved for producing the ammonia from the first and second method is Haber-Bosch, from the steam methane reforming method. So what exactly you are doing is you are using methane to convert methane into hydrogen. Hydrogen can be reacts with hydrogen reacts with the nitrogen in the Haber-Bosch reactor at a temperature of 350 to 450 degrees centigrade. At a pressure of 200 to 300 bar pressure, we are going to produce the ammonia. But ammonia coming out, along with that CO2 also coming out. But the CO2 is not going to be recovered; it is going to be sent to the environment. So this is going to create I can say, lot of hazardous to the environment where the plant is located. Whereas here, the blue ammonia, same method, but we are going to produce the ammonia along with carbon monoxide, carbon dioxide. The carbon dioxide can be recovered, right? Carbon dioxide or carbon emitting pollutants CO or CO2 will be captured before we send it to the environment. That's called CCU, carbon capturing unit, going to be installed after this Haber-Bosch reactor. So ultimately, we are going to produce ammonia, which is free from carbon dioxide. We are not sending to the mixed with the air. Maybe the carbon sequestration methods are there to store the carbon dioxide for maybe producing the synthetic fuels in the near future. Then the third method is the area where a lot of research is going on. It's called green. That means the energy consumption is also green from the wind or solar PV. Here, what exactly you are doing? You are going to split the water into hydrogen and oxygen. You are going to split the air. As you know that air contains 79% by body nitrogen, 21% by oxygen. So the nitrogen reacts with the hydrogen comes out from the electrolyzer. Nitrogen comes from the PSA, right? What is PSA? Now pressurized cell absorption. Okay, so membrane kind of concept where the nitrogen alone spreads similar to the Vmax, right? We are breathing air, but what exactly you are doing is the membrane is inside, it's going to separate out the nitrogen from the air. So I can say oxygen allows enter into the system for doing a combustion or consuming the food in the hydrocarbons is going to be combusted. So here we don't want oxygen, we want only nitrogen. Here we don't want, I can say, oxygen or OH minus, or can say oxygen from the water, we want only hydrogen. Hydrogen reacts with, I can say, nitrogen, we are going to produce the ammonia. So ammonia is not a Haber-Bosch method. We are not going to maintain the pressure of 200 to 300 bar. We are not going to maintain the temperature of 200 to 350 degrees centigrade. We are even able to produce the ammonia at local ambient temperature and pressure by using the plasma technology. So here there are different energy densities of fuel. So you may be knowing that among the different fuels, diesel is having higher energy density, which can able to produce the energy content by burning unit mass of the fuel around about, I can say, 45,800 kilojoules of heat will come out by burning 1 kg of fuel. So next to the diesel is petrol, then liquefied petroleum gas, ethanol, LPG, methanol, ammonia at minus 35 degrees centigrade, having more energy than the ammonia at 25 degree positive temperature, hydrogen liquid, hydrogen at 700 bar, hydrogen at 350 bar, lithium battery. So among these we see that the conventional fuels are having more energy density than the fuel we are going to export it from the conventional method of producing ammonia or hydrogen or from the green method. So the challenges are how to match this lithium-ion battery energy density with the diesel, how to match the hydrogen at 350 bar storage pressure, 100 bar storage pressure to match the diesel or petrol in the internal combustion engine, how to match the energy density of ammonia at minus 35 to diesel, how to match the ammonia at 25 degree to diesel. These are big challenges because storing diesel and petrol is very easy because if you want to store 30 liters of petrol or diesel, it may not take more than 5 minutes time. And you can store it and you can move the vehicle as quick as possible. Whereas for storing the electricity in the battery, even then supercapacitors are available in the market and lithium-ion batteries are available. So even the charging may take half an hour. So you can move the vehicle if the battery is getting drained out, you have to stop the vehicle for half an hour at least to charge the battery. So purposefully you need to stop a vehicle. So when you want to travel from Trichy to Chennai, you have to have the break at Vilupuram to have lunch or dinner or breakfast to charge the vehicle. So it is mandatory. So you cannot say that within 5 hours or 6 hours I can reach Chennai like by going by petrol car or diesel car. EV, it is not in our hand. Charging and discharging is not in our hand. Okay. So a lot of research is going on in this EV side. And apart from, I can say, focusing on EV, people are now forget about EV, direct EV, they are going for hybrid vehicles. The hydrogen can be utilized for engine, hydrogen can also be used for fuel cell. Similarly, ammonia can be used for engine because storing ammonia at minus 35 or 25 degrees can energy density more than that hydrogen. Because taking hydrogen at 700 bar and 350 bar, that's nothing but you are carrying the bomb in the vehicle. Okay? Because of the low molecular weight, to produce the same energy density of diesel, you have to store n number of cylinders. So apart from carrying the passengers, you are carrying the cylinder. You are carrying the bomb along with you. It's very dangerous. That's why people are moving towards ammonia because we can store at 25 degree or even at I can say liquid at 25 degree. The problem of at 1 atmosphere you can store or maybe 1.52 bar you can store it. The problem of this much pressure is the energy intensive process. Rather than producing the energy, you are consuming a lot of energy to produce the bomb. Okay. So properties of various fuels in terms of the value. You can see here in terms of unit mass, hydrogen is going to be higher value, but to carry 1 kg hydrogen, have to take n number of cylinders with you because of molecular weight. This molecular weight is 1. Okay, so ammonia you can see here 18.6, gasoline 42.3. If you burn 1 kg fuel, it produces 42.3 megajoule. If you produce 1 kg fuel, maybe see that it is having high energy, high calorific value. But producing this much calorific value, you have to store 1 kg, it has to need lot of cylinders. Okay. So what is the future for green ammonia? So ammonia is easily stored. It's not like storing hydrogen. So you know that boiling point of ammonia is -33. You can separate out ammonia which is coming out from the reaction. You can store it at 10 to 15 bar. Very easy to store it. You can store it in the form of liquid. Something like the storing LPG. Stored in the form of liquid, it comes out converted into gas. So you can use that ammonia for the internal combustion engine. Also, you can use ammonia in the fuel cell. The people are lot of this is going on in using ammonia as a raw material for producing the electricity from fuel cell. Or you dissociate the ammonia into hydrogen in the onboard, very easy to dissociate. Then the ammonia, hydrogen can be used for engine, or hydrogen can be used in the hydrogen fuel cell. Okay. So the electric vehicle is a big issue for heavy vehicles, particularly in marine industry. So the ammonia, if you are able to use it in the marine industry, you can store it in liquid. So a lot of advantages in taking ammonia as a fuel, particularly for marine industry. You can store it whenever there is a need of ammonia, you can fill it up. It's not very easy to store the hydrogen, store in the form of gaseous form, even at 350 bar. So we are going to use nitrogen in a PEM electrolyzer, PEM fuel cell, polymer electrode membrane fuel cell. So this is working exactly opposite, exactly working at opposite to the battery. So the battery is storing the energy. Whenever you need power, it will be going to be given to the particular application. Whereas fuel cell, you are going to produce the electricity from the system where you have similar system, anode, cathode, and electrolyzer, where you are going to produce the electricity. How green ammonia is produced? So combining, I can say Haberforce is the method. It's a conventional method. It's a very proven method, and I can say it's a constant ammonia generation is possible. But here we are planning to go for renew because you need to operate at very high pressure, energy intensive process. So people are thinking about producing ammonia even at atmospheric condition. So we are planning to going for electrolysis based system. So conversion. So you can see here, electrolysis is the process where we are going to convert water into hydrogen. Hydrogen can be liquefied. Then the hydrogen can be given to the ammonia generation system. Hydrogen reacts with the nitrogen, produces green ammonia. Hydrogen also reacts with CO2. So CO2 we are producing from SMR. So if you combine CO2 and hydrogen, we are able to produce the methanol. So how to recover the carbon dioxide or carbon products without moving to the environment? This is a concept. So you can react the hydrogen with carbon dioxide by using a suitable carbon dioxide capturing technology. You can convert the waste CO2 into a fuel. You can able to produce the methanol, which has a lot of scopes in, I can say, pharmaceutical applications, then the food industry, then the fuel cell application and engine application. So how this is going to be transported? So it's going to be through pipeline. Then I can say green ammonia methanol can be used in the fuel for marine industry, and also it can be transported through trucks. You can transport through shipping also. For shipping, you can transport it, but you can use the same. You can say both the fuels for fuel also to move the ship. And end use, hydrogen can be used for heating. Steel industry, lot of steel industries are now moving toward the hydrogen as a fuel for producing the heat. Chemical industry, refineries, then the power generation. Hydrogen, ammonia or methanol can be used as a fuel for producing the power. Either from the fuel cell or from the, I can say, gas turbine or from the internal combustion engine. Particularly the ammonia, hydrogen and methanol coming out from the hydrogen, which can be used as aviation application, shipping industry, rail, cars, trucks and buses. So sustainable electricity, I can say we are going to put the green ammonia through sustainable electricity through the solar PV or wind or renewable energy based. So water is electrolysis process, water is converted into hydrogen. Then we can bring the hydrogen for Hyperbosch, one of the concept, produce the ammonia. Sustainable electricity we are producing, we are supplying to the Hyperbosch system to produce the ammonia. So we are not converting natural gas into ammonia, we are converting water into ammonia through renewable electricity. So the ammonia, what the application of ammonia is? Fertilizer, existing use, refrigeration, explosives, textile pharma industry they are using ammonia. Expanded use, after cracking this ammonia, we can use polymer from membrane fuel cell for producing the electricity, which can be have a lot of application in aviation as well as the internal combustion engine, particularly for automobiles. They are using alkaline fuel cell, we can able to produce the electricity, we can use either hydrogen or we can methanol, we can use directly as a raw material. Direct combustion engine, like how the petrol and diesels are burning out to produce the power from the internal combustion engine, then gas turbine also. Transport fuel, direct combustion, directly used as solid oxide fuel cell and fuel cell gas applications. We break for this. So we break for 15 minutes. Okay, I will meet around, I can say 4:45. I will try to close the presentation by 5:10. Okay. So you have any questions?
We are using smaller PV panels. So it will be, we want to be, how you can reproduce that panels. After some anyway, 10 years or 20 years, want to dismantle it.
Yes.
It will,
So
scratches.
you can use as a raw material for, I can say, but maybe I can say I'm talking about the plastics and other things. You can use it to convert it into, I can say,